But we're going to talk about some of the stuff that was in the reading, and we're going to go ahead and talk about the project, which you have. Today is Wednesday, so I'm going to give you time to work on Friday, and presentations will be next week, first class. Okay. So if you don't get it all done on Friday, then you have homework over the weekend on the presentation. Okay. And you have to get those other assignments done. So, purpose of the first thing, we need to make sure you understand what the purpose of the hard drive is. Mr. Plankenborn, what is the purpose of our hard drive?
It's a secondary memory storage, isn't it?
Secondary what?
Memory, or isn't it?
Is that the right word?
Or storage?
Secondary storage.
Yeah.
What is secondary storage, Cody?
Permanent, I guess is the best way to
Okay, it's permanent. Why do we need that, Isaac? I'm sorry, Ian. Isaac's like, you only asked me a question. Why do we need permanent storage on our computer? Why?
store operating system.
Okay, holds our operating system and our, Cody, what else is on there?
Our drivers.
Okay, and yeah, I'm going to put that in there, drivers. That's embedded in the operating system. What else do we need? Do we store, Brandon, on our... Did you bring that PC in? You didn't bring that.
No, I don't have a car to bring it in.
What? You don't have what?
There's a car to bring it in.
Oh, okay. What else does it store?
Files.
Okay, it stores our files. What else does it store?
You don't have to.
What's Word? Word is a
It's a software.
software or programs, right? Okay. So without that permanent storage, we'd have nowhere that our operating system, which is our largest program on our computer, is stored. We'd have nowhere for our programs that we run and the files that those programs save. And those are the biggest things, right? And there's other things, obviously, we store in there. We store media, video, pictures, and that's all obviously under files. But all those things are there. All the files are parts of things that programs store, right? Even a picture is opened with a program. And videos are opened with programs. So those are really the big things. So the purpose of the hard drive is to house our operating system, and it's to hold on or have our place for our programs, because obviously if these things went away when they turned off our computer, it would be bad, right? It's kind of like what Brandon had when he reset up his computer. It's like all of a sudden, my bricks is gone. Okay, so that's the purpose. The purpose of the hard drive. And we have different things that define our hard drive. Okay, we have different form factors of hard drive. And when we talk about form factors of the hard drive, we're talking about a number of different things. One of them is physical size. What are the physical sizes of hard drives? Anybody know what the dimension sizes are?
2.5 inch, 3.5
2.5 inches and 3.5 inches.
I've looked at enough of them over the weekend now.
Okay, those are our two dimensions of hard drives. 2.5 inches are traditionally what kind of hard drives?
Should I guess and say laptop?
Laptop, right? And 3.5 inch ones are traditionally desktop. Okay. Now I say traditionally because all SSDs, which you guys hopefully watched on your videos, are 2.5 inches. All SSDs are 2.5 inches, or not traditional shape at all. But since all SSDs are 2.5 inches, we've gotten to a point where, okay, 2.5 inches are traditional drives, or for laptops, 3.5 inches are a traditional drive. And this is, by the way, if you don't know, this is 3.5 and this is 2.5. Okay. And we're talking about the width of the drive. This one is 1 inch bigger than the other. Okay. So we've got physical size differences that help define the form factor, and every laptop takes a 2.5 inch. No laptop takes 3.5 inch. Every desktop takes 3.5 inch. Some desktops take a 2.5 inch. Depends on the desktop. They're all made to take 3.5 inches, which is why we have adapters and stuff that make a 2.5 inch drive into a 3.5 inch drive. Some computers, many new cases anymore, come with at least one spot that's made to hold a 2.5 inch. But they make these little adapters or many things like this. I have a whole box of a different kind of adapter that turns a 2.5 inch into a 3.5 inch and then connects into a traditional one. So we've got physical size differences. We've also got connectivity, and that was the purpose of the one connectivity. And what are the two connectivities that you guys watch videos on and read about right now? Those are Peta and SATA. Okay? And there's another one that I don't have a video on called SAS. Okay? SAS connectors are very similar to SATA. Okay? In fact, the PC that Brandon bought on the auction from the school has very nice SAS drives. They're more enterprise drives for servers and stuff, but that was the only machine we had in the whole district with SAS drives, so that's why I was like, I'm not going to pull them out. They're brand new, almost unused, yeah.
Is it a good idea to get a solid state drive just to hold the operating system?
Well, we're going to talk about that. We're not there yet, but obviously yes, or we wouldn't have solid states on every single thing in the district. Okay. So when we talk about form factor, we talk about physical size, we talk about connectivity, which should be one of these, and then we talk lastly about capacity, or how much they store. Okay, and there are other things that define a hard drive, but a lot of times when I ask how big it is, people don't understand whether I'm talking about physical or capacity. When you ask how big a hard drive is, usually you're asking capacity. Okay. And that's how much data a hard drive can store. When I first started in computers, my first computer was like this one over here with absolutely no hard drive. There had two floppy drives in it because hard drives didn't exist on personal devices back then. The first hard drives were 20 meg, and we thought that was huge. It seemed huge because a floppy was only a half a meg, so you could all of a sudden get 20 on a hard drive, and then they went up to 40, and then we had this limitation of 2 gigabytes for a long time, and now we're up to, you can buy an 8 terabyte drive reasonably online anymore. So they're huge. The capacity affects other things, and we're going to talk about that in a little bit, because obviously the more data it stores, the more time it takes to get to that data. Okay? If we had a library with 4 books in it, and Ian went to check out a book, the checkout time is going to be pretty quick, right? He only has 4 choices. If we have a library with 5 billion books, and I send Isaac to go check out a book, it's going to take Isaac longer to find the book he wants. Okay? So the larger capacity a drive is can affect how long it takes to find the data and get the data off the drive. Okay? So people think, I'll just get the biggest drive I possibly can. It does affect you at some point. Okay? Not in a huge way, but there is an effect when you get to a larger capacity drive. Okay, so those are the sizes we talk about. When we talked about connectivity, there's 2 different ways to connect. This one is which one, Isaac? Peta or SATA?
SATA.
Okay, right, that one's SATA. And Ian, this one is then Peta. Okay? Peta is old. It's the original way we connected up hard drives, and we evolved into SATA. Anybody remember what the fastest Peta drive was as far as transfer rates? Okay, the fastest Peta drive was 133 megabits per second. Okay, went up to 133. Anybody know what the slowest Peta drive is?
It's like 150.
Right. So Peta, I'm sorry, I said Peta, I meant SATA. The slowest SATA started out at 150. That was SATA 1. Then went to 300. That's SATA 2. And we're now at 600, which is SATA 3. Okay? So why would we ever want a Peta drive anymore? We wouldn't, right? Because we're easily 5 times
I
faster.
actually bought one for my laptop once.
And here's the thing, if that's what your laptop takes, that's all you can get.
It took the other
Okay.
one and just didn't show the pins on it. Everything else was like almost the same. It just never showed me the
It
pins.
just looks very similar,
And
right?
then when I got it,
And then you get it and you're like,
pins.
Well, and if your laptop takes Peta, that's all you can do. And we had a bunch of laptops that took Peta drives, and there's nothing to do at some point to speed that thing up. That's the fastest. In fact, that's the fastest that Peta ever got to. Most Peta were at 100 megabits per second. Okay, most of them were actually at 100. So if you have a laptop that takes a Peta drive, and that's all it's ever going to take. It's not like an adapter that fits in a laptop. There are adapters, okay, that you can hook a SATA drive to a PATA connection, but this is still the speed. Just because you can hook a SATA drive to it doesn't mean that it's transferring faster. It's still going to transfer at that speed, okay? And vice versa. You can hook a SATA drive. There was a period of time where we had tons of PATA connections. I have it. I used to have a bunch. I may have thrown them all away. So this adapter right here lets you put a PATA cable and a PATA power in one side and connect it up to the SATA on the other side. So it just plugs into the back of a drive and then connects up. And where I only have a few of these left, but so they can communicate. It's not like they can't communicate, but that's the speed. Or that's the speed. They don't. It's not like making it connect to another cable all of a sudden makes that cable faster. Okay, so SATA replaced PATA. How many things could go on a SATA or PATA cable when we plug them in? You guys remember that from your reading? How many different devices could go on a PATA cable?
3. I was guesstimating.
Okay, how many can go on a SATA cable? 1. There's 2 ends of a SATA cable. Okay, but on a PATA cable, you can put 2 devices on each one. One goes in the motherboard, obviously, and then I have 2 things that can plug in to PATA. Okay. Which is why that one thing talked about master and slave relationship on PATA. It was a big thing that used to affect students all the time because you could only have 1 master and 1 slave on a cable. If there were 2 masters or 2 slaves, there was nothing. Nothing talked. Okay? Something had to be in charge of the data and something had to be, it's called master slave. The other one was secondary. And those relationships were set with this jumper pin right here. You had to find either the online guide to that hard drive, or sometimes the hard drives had them right on the hard drive, but you had to physically pull this jumper off and put it in the right place so that one was master and one was slave to have the 2 things work. And it used to be a big gotcha. People would put in an additional drive and just plug it in, and now nothing works because everything usually comes from the factory as a master. So if you just plug it in, then they're both masters, and now the computer doesn't boot at all. That problem went away with SATA because SATA only has 1 connector, and it's virtually impossible to plug it in incorrectly because of the way the bracket works. It's a little L on the end on that, so you can't put it in the wrong way. You can't. It's hard to see the notch right here, but it goes over and up. This one actually you could put in the wrong way. There's 40 pins on there, and let's see if any of these are. Now, you can see there's 1 pin that's blocked out. So as long as you looked real good and said, oh, that's where the missing pin is, it goes in just like this, that's fine. But if you're a ding-dong and you just started shoving, you could easily shove that extra pin down into the motherboard or squash it. Now the motherboard's ruined. You can't use that spot anymore. So it was easy to really mess up with a PATA drive as well. So now we're at SATA and SAS. Drives, and I really don't talk about SAS because that's not a normal drive to use in a home PC. Okay, they connect the same. The adapter is a little bit different. The power is the same, but this plug is a little bit different on a SAS drive. But they work just like a regular SATA drive. The transfer rates are the same as a regular SATA drive. Okay, so here's the cables for the 2, and this one we have to worry about the master slave, and this one we just plug it in. However, we can't just plug it in because on the motherboard there's a number of different connections for this. On this, there was a primary plug and a secondary plug. And BIOS assumes that you're going to be, if you're the operating system, you're going to be plugged into primary and you're going to be the master. And that's where it looked for the operating system, unless you told it otherwise. On SATA, there's a 0, there's a 1, there's a 2, there's a 3, depends how many there are. It could be up to 12, because I've never seen one with more than 12. And BIOS expects it to be here. And if it's not there, it'll look there. And if it's not there, it'll look there. But it's the same thing. Just because it's plugged in doesn't make it right. In fact, many computers, when we fog automatically goes to SATA 1. So we, when we plug stuff in, always put the CD-ROM on 0 so that it can't ever get confused. It can't image to a CD-ROM. And then we put the operating system on SATA 1 and then any other ones on the other ones. We made that mistake with a couple when we first had them hooked up because we had the operating system on 0 and the teacher's data drive on 1 and it went and wiped 1 when we thought we were wiping this one, which is why we started doing it this way. Because it'll look for the operating system at 0. If you got it on a CD, that's fine. If not, it'll go to 1. But when we fog, it seems to fog always to 1. And some motherboards start at 1. So some of them say 1, 2, 3, 4. Some of them say 0, 1, 2, 3, which is why it's confusing. Fog just says I'm going to 1. Okay, so that's different ways that we can connect up. And we already talked about this, the speeds. Really, most PATAs went to Ultra ATA 100, which was, like I said, at 100 megabytes per second. And they went up to 133. And then SATA started out at 150 megabytes per second. And then now we're up to 600 megabytes per second on SATA connections. We're not going to spend any more time on PATA connections because you don't have any in the whole school that have SATA anymore, PATA anymore that I know of. If you ever have a problem with that and you want me to help you, and I still have a bunch of PATA cables over here, but I can't even get a PATA CD-ROM because for a while we kept using our PATA CDs. But I don't think we have a single one left up there. They're all set up here. Let's see if there's any. Not a single one. And it wasn't a big deal that we kept using PATA for the CD-ROMs because CD-ROMs are slow anyways. PATA cables transferred CD-ROM data as fast as it could be read anyway. It only really affected hard drives. So when we hook up SATA though, it's just a single cable, goes to a spot on the motherboard. We got to remember the power. And I will say the different hard drives, some of them have both power connectors. You never hook up both power connectors. It's an either or. This one only has a SATA data connector and a SATA power one. The long one's the power. But I don't know if I have any left over here. Some of them had both. So depending on what kind of drive and what kind of power connections you had available on your motherboard, that's a big drive. Let's see if there we go. Like this one, you could do a traditional Molex power on here, or you could do that. But I've seen students just, if there's a spot, they plug them in. It's not both. It's one or the other. Okay, so either I'm plugging in Molex or I'm plugging in SATA. So just decide which one based on what power connections I have left. The motherboard connections can look a number of different ways. You have to actually look at the motherboard to see what's 0, what's 1. If I look at this one, let's see. I should have rotated that picture the other way because it's upside down. It looks like we're going SATA 0, 1. Oh, look, it's a SATA 2. That's what it's. SATA 2, 0, SATA 2, 1, SATA 2, 3, SATA 2, 4, SATA 2, 5, SATA 4, 5. What? 0, 1, 2, 3, 4, 5. And then up here.
I think up there's the 4 and 5.
I think it's.
I don't think they organized that very well.
I can't read one that's up here. No, I guarantee. Well. I don't know. That one's not written very well, and this one I can't read very well what these are, and that's why I said I would look at the manual to make sure you're plugging it in. But you can see they can go straight down, or they can go from the side. This one obviously has 10 SATA connectors. They're always in pairs. I've never seen a single one off by itself. In other words, I've never seen an odd number. I've never seen 3. There's usually pairs of SATA connectors like these are on a motherboard, so you almost always have an even number of SATA connectors, okay? And the way I plug these in, I already went over once, but there are other ways to plug them in. There is some significance to the color difference between these and these, okay? These may be SATA 3s and those may be SATA 2s, or it may be that these are grouped together in a way that you can do RAID connections on them. And RAID is a way to organize drives for data redundancy and data protection. Okay, so for instance, in fact, I don't have a slide on that. I should. Let me pause while I turn this on, and I'll just go through this graphic, and I'll try to find one later. So RAIDs allow you to arrange your hard drives in a way that protects you. Okay, so RAID 0 is a way to connect up your drives, and this is basically saying that you've got two drives. They have to be completely identical drives to do RAID 0. And what RAID 0 does is every time it writes to one drive, it writes the exact same thing to the other drive. So if all of a sudden you have a drive that dies, you don't lose anything. It's just sitting there making copies the whole time. Okay? Now, as you can imagine, this is more intensive on your motherboard, because now your motherboard has to send double the data across two different SATA cables every time it writes. Okay? So RAID 0 is called striping. Oh wait, no, I'm lying. RAID 0 is, I'm lying. I'm talking about RAID 1 instead of RAID 0. RAID 0, there is no redundancy. RAID 0 actually is the fastest way to do it. Sorry. Because it will take turns writing to drives. So if it's got something to write over here, then it can write over here, it can write over here. There's no redundancy, there's no fail-safe. If one of the drive goes away in RAID 0, it's actually bad, because usually everything is gone, but it allows you to write faster. Okay, and when I was just talking about, RAID 1, which writes them both at the exact same time. So if one drive goes away, the other drive is there with all the data. Okay, which takes double the amount of drives. Whereas RAID 0, you're spreading it across the two drives. RAID 1, you're mirroring it on the two drives. Then there's RAID 2, which you can set up with a various number of drives. And what it does is it goes and stripes across multiple drives in order to make your data spread out. But like it says, it's really no longer used because people use RAID 3 instead. What RAID 3 does is it spreads your data across multiple disks. And the idea with RAID 3 is you're supposed to be able to lose a drive, because if you look here, A2 exists, should exist somewhere else. Let's see, where else is RAID 2? I don't even see it on there. By the way, I never set up with RAID, but there are different ways to do it so that you get more redundancy and backup of your data. And obviously, if you look, it takes more and more disks to do different RAID levels of writing. Okay? So this is something people do on servers, not on normal machines on a normal basis, which is why I don't spend a lot of time talking about it. Okay? But if you buy a really good controller, RAID can speed up your write because you're writing to multiple drives at a time if you spread it across multiple drives. But the problem with RAID is when you lose a drive, I have yet to ever recover anything from a RAID array. Supposedly you can. Okay, I've read a lot of guides on how to do it, because we had a system set up with RAID. Even the RAID 1, where it mirrors, the problem was that we had on a server one time is it was the teacher drive, and I had it set up RAID 1, so it's writing everything here the same time it's writing here. However, this drive dropped offline 6 months ago. Stopped copying. System didn't tell me. No way to even know. So then when this one died, and I was like, oh, it's okay, I've got the other one. And I go and I was like, oh, the other one's offline. I bring it back up online, and all the data was 6 months old. So it had been copying to both drives, and then all of a sudden it stopped. I didn't know. And then this one died, and oh no. So I lost my confidence in RAID arrays really at that point. So. But just so you know, if you read anything on RAID, it's a way to arrange your drives to back up your data in a different way. Okay, so how do hard drives work? Hard drives are multiple platters that spin in unison. There's only one thing turning them all. They all turn together. Okay? There's one head that goes across the drive that finds the data and reads the data. All the heads move across in unison as well. I've got a good picture of it. And that data is divided up. So I've got another picture. So there's a spindle. This whole thing spins together. Now, as we look at hard drives, there's different speeds that they spin, and this rotation speed definitely affects a lot of stuff on our drive. Okay? So, rotation speeds. The lowest level rotation speed used anymore is 5,400 revolutions per minute. Okay? That's slow, and if you see anything that says it's a green drive, it means usually that it's a slow drive. It uses less power because it's spinning slower. Okay? So 7,200 is the next one, and 7,200 RPM is what I would consider our standard speed. 90% of the drives that we have at National Trail are 7,200 RPM. Majority of the drives that you look at that are high quality are 7,200 RPM. As you guys look at buying drives, you should be looking at 7,200 RPM. It's a third faster than 5,400. There are faster than 7,200. Okay? So we have some drives that are 10,000 RPM, and there are some that are 15,000. As far as I know, that's the fastest, although I did see a 20,000 RPM once, but I haven't seen that in a while. So the ones that we have that are 10,000 RPM look like, do we have a Velociraptor sitting out here anywhere? I know we did. I think will you go grab me a Velociraptor out of the closet? Please, sir. We have ones that are called Velociraptors that get hotter and they spin faster, and they're more expensive of a drive that are in the 10,000 RPM range. And when we're talking 10,000 on up, we're really talking high performance servers.
So 5,900, not so much.
5,900 is usually a green drive, and that falls in this category. 54. That's why I said 5,400 is the slowest.
All right.
There are some other speeds that you're going to see in between there, but those are green drives.
So I sent you an email. Ignore the hard drive on it.
Yeah. So if you see 5,900, it's a slow drive. Now, is it? Some of them that say they're green drive give no speeds, because what they do is they spin at a normal speed of 5,400, and they have the ability to speed up while you're reading and writing data. So this is what's that one? Oh, where did we get that one at?
Had it.
Huh?
We've had it.
You've been hiding that one. Is this a SAS drive?
Yeah.
Okay,
It's
so
only
this is a Velociraptor right here, and the Velociraptor is kind of an odd size, and it sits inside a heatsink. That's all this is here. You can unscrew the drive from there, and you can put a traditional 2.5-inch drive inside a Velociraptor case, but this whole thing is really a big heatsink to cool this drive, because it gets hotter than a normal drive. So this one spins at 10,000 RPM, and this one is a 160 gig Velociraptor. This connector, you can see it looks a little different. This is the connector for a SAS drive, okay? And this SAS drive is a 15,000, that's why it says 15K. It's a 15,000 RPM drive. How big is this one?
146 gig, I think.
It's a weird size. So it's not super big, but it connects with a little different cable, but it connects basically like a SATA cable does. Just plug it in, there's one per drive, and that one's fast. So they spin at a certain speed. Now, do you think that speed affects how fast it can read and write? Sure, because that's how fast it goes past that head. There's only one spot on every disk that's red. It's got this actuator arm that moves across all the disks at one time, and on the top and the bottom, so here's the platter, and here's the arm. That arm has a read-write head for the top and bottom of every single one of those platters. So it's this big, in fact, I think I have a better picture. Let me see if I got a better picture. There we go. So it's this big arm that goes across here that, because it reads and writes the top and bottom of every single one of those. Okay? And the distance between that read-write head and that data is in microns. It is so close to that. Doesn't actually touch it ever, and if it does, ouch. It's not supposed to. Okay? So this drive is spinning really, really fast. I mean, even at 5,400, that's 5,400 revolutions per minute. That's going pretty fast. And when you get up to the 15,000 range, it's going really, really, really fast, 3 times faster, right? And then you've got this head that's sitting over here that's so close you almost can't even tell that it's not touching. Okay? So the thing with this is temperature affects it a lot. What happens when things get hot? They expand, right? We know that from science class. So if this metal disc expands and the distance is really, really, really close to that metal disc, what is the possible outcome of that event?
It ratchet.
Then all of a sudden touches it. Okay? All of a sudden, the thing that was really, really close, reading by the use of magnets, basically, it's magnetically changing the writing on this from 0s to 1, which is why magnets in your hard drives are bad. You can erase all the data on a hard drive with a good magnet, and it's all gone. Okay? It writes magnetically to this thing by changing things from just 0s to 1 all over this drive. And if it gets hot and it touches, it's not ever supposed to be touched. These are sealed, so no air, no dust, nothing ever gets inside them. It's the only thing on your computer that's completely sealed so that no air can get, or no dust or contaminants can get to it. And that would be really bad. So when we used to have, and I say this used to have, every year I had a server drive fail. Every year, guaranteed. Because that closet would get to 130 degrees. And it would get to 130 degrees in the closet. What's the temperature inside the system? How hot are those hard drives getting when I've got multiple hard drives inside a server? Every year I'd have to rebuild a server. So I got a little temperature thing that emailed me and the head of maintenance every, 2 minutes? Every 2 minutes the temperature was above 85 degrees in that room. And I was spamming the heck out of them. Just emails. Every 2 minutes you get an email. He's like, why do I keep getting this email? I'm like, because the temperature above 85 degrees. When is that going to stop? I'm like, when the temperature is not above 85 degrees. They put blowers in there. They left the door open. I had multiple problems. I had a big heat vent in the ceiling, and I had a side heater that was always on, even when that room never needed heat, right? I've got all those servers in there. So heat is bad on PCs, and that's why. Because there are places where the distances are measured in microns, and by flexing the temperature, if it gets colder, what does that hurt? It shrinks, right? It doesn't really hurt anything, although I suppose if it got cold enough, it could shrink so much that the data couldn't be read because the head was so far away, but I think we'd have other problems if it got that cold. Okay? So our data is saved on that hard drive, and there's another picture of the whole secret arm that moves across there all together. Our hard drive is built on this structure and how data is stored on it. And everything is stored in 0s and 1s on the hard drive, and it's built on these sectors and tracks on your drive. Okay? So think of it like a track is like a lane on a track course. Okay? Like outside on the track. And that's broken up further into little sectors of data on your hard drive where information can be written anywhere on the hard drive. Okay? So one of the terms I want to talk about right now is fragmentation. Okay? Fragmentation is when, if I had a piece of data, okay, let's say this is a program. It's that big. Okay? And if it was written on this drive like that, it would be awesome. Okay? But if it was written on the drive like this, what happens when I go to read that information? It's slow, right? So if I took a book in the library and I said, Isaac, I want you to go check out this book and read this book in the library, and I say, Ian, I want you to read a different book. However, the last kid who got it was a cretin, and he hid the pages all over the library. You have to find each page. So I ripped out all the pages and I hid the pages around the library, and you both had to go read chapter 2. Who's going to read chapter 2 faster? Isaac, because they're all together, right? Whereas Ian is running all over the library trying to find the next page. That's what happens when we have data fragmentation. If they're all over the drive is literally going like this as it's reading. It's going to get the same data that I might just go boop and read. Okay? So data fragmentation is when data is moved all over the place, and I've got a little data fragmentation story. When I was in college, I programmed a system called the time of use billing system for Dayton Power and Light. And the time of use billing system worked, basically the way it worked is that it read your meter every 15 minutes and sent this data to the program that I was on the project team that we wrote, and it billed you based on when you used your data or your power, not just how much power you used. So we're trying to get Isaac's family to use his power between 6 o'clock at night and 6 o'clock in the morning. So we literally paid 1/10 the cost for his electricity between 6 o'clock at night and 6 in the morning. But between 6 o'clock in the morning and 6 o'clock at night, during the daytime when all the factories are open and all the businesses are open, he was paying double for the electricity. Okay? So instead of you just paying this amount per kilowatt, you're paying twice as much during the day, but 1/10 at night to try to get you had to agree to be, there was 1,000 customers on the system. To try to see if it, first of all, would you change the way you did stuff? Do your laundry after 6? Put a timer on your hot water heater so it doesn't come on between 6 and 6. So you had to get your shower in early, be first, because if it's electric and it came on later, that would be bad. You get a nice cold shower. So every month, or every day, there was this audio engineer. They kind of like paid different for engineers. I wrote the program. She printed out the bills, folded them, and mailed them. She got paid $5 more an hour than I did because she had engineer on her degree. Anyway, so she would print them out in the morning and then mail them out every day. And she called us up and said, hey, I start the print by 9 o'clock in the morning and they're not done by tomorrow. So what used to take basically an hour to print was taking 25 hours to print. And that's what it was. We went over there, defragmented the hard drive, and went back to take an hour to print. She would literally start the print, and she would wait like 30 minutes for each page because the data was so fragmented because it's getting sent in every day and the data's every 15 minutes, and the drive got more and more and more and more fragmented over time that all we had to do was defragment the drive or get rid of the fragmentation, and all of a sudden it ran really fast. So data fragmentation can really, really affect you. So what do? And while we're talking about this, we're going to go and talk about the tools available to you to defragment a drive. Now on Windows 10, I'm going to open this up and it's going to go to the other window. In Windows 10, there are tools to defragment, and I'm going to tell you that traditionally the Windows tools are stinky. Okay? Windows tools are not great, but I'm going to show you the Windows tool first. So if I go to this PC and I'm going to pick this drive, and I'm going to go to Properties. One of the things I see on here is the tools, and one of the tools says Optimize. So if I click Optimize, it says Optimize your computer drives can help it run more efficiently. So if I hit Optimize, and nothing's opening. Why is nothing opening? Hello? Hello, Windows. There we go. Boy, that took a long time. Okay, and now I got to open 3 times because it kept running. Okay, so right now it says it's 0% fragmented, and that's because I have it defragmenting automatically on my computer. I'm going to open up a server so that I can show you what a fragmented drive looks like. Let me open up a server here. The fact that it's a 2008 server. Okay, so I'm going to look at this backup drive right here, and I'm going to analyze the disk. And when I do that, the Windows analysis is stinky in compared to some of the other tools that I'm going to show you. So right now it says it's 5% fragmented, but it doesn't let me see any kind of graphic of what that means. So I think, do we have AS Logics on this one? I think we do.
Should.
Defraggler? I can't believe.
Yep.
There we go. Is that no? That's their
That's
defraggler.
theirs.
Allows you to get software packages without all the extra crap. Okay? So when did I spell it right? There we go. So when you go to Ninite, it lets you pick from all these different software packages that you can install, and I'm just going to install one right now. Should be under utilities, right? Where am I looking? Is it not on there anymore? Garrett, do you see it on there anywhere?
What?
Is it under utilities? It's not on there.
Yeah, it's not on there.
Well, poop. So here is Defraggler, and Defraggler looks a little different. But if I go, there we go. If I go, and I'm going to go to the main backup one, and I'm going to do analyze. Sure. What Defraggler does that the Windows diagnostic tool does not do is it gives me a nice graphic of what the disk looks like. Now, as it builds this picture, red is bad, green is good. So the more red we see, the more fragmented the drive is. Now, Windows said it was 5% fragmented. So we'll see what Defraggler says. And the AS Logix tool does the same thing as Defraggler. It gives me a very good look at it. This one, as does the AS Logic one, lets me set a schedule. This is a free program. Lets me set a schedule. I have my hard drives at home set to defragment every single night between 2 in the morning and 6 in the morning. It just does it on its own. So my drive is always defragmented. So I don't ever, and which is why this one's defragmented too, because I have a schedule that automatically does that. The first time you go and defragment a drive, it is really, really, really slow. Could take hours depending on how fragmented your drive is. But after that, the defragmentation process is really relatively quick. It takes an hour. And what it does is it reads everything on a program, writes it all together. Reads everything on a program, writes it all together. So look at this drive. Ouch. Okay. Now Windows just said it was 5% fragmented. Look at this, Garrett. Windows said 5%. This says 88%. Okay. So how much credit do I give the Windows program? Not a heck of a lot. I would say that one sucks. Okay. If I was going to use that word. Now the other thing this one does, it lets me click on it and see what all exists on that fragment as well. I can see what things on this one section of drive, all these files exist on there. Okay? It also lets me go and defragment only a single one. This one has 67,904 fragments on it. Ouch! That is a pretty fragment, and if you imagine, now these are all backup files, okay? No one's reading them, only I'm reading them, and that's why they're so fragmented. Because the way it works is, when it goes to write something, okay, it goes and says, I got a free spot, got a free spot, got a free spot, got a free spot, got a free spot. That's how Windows writes, okay? It just writes wherever it can as it goes, okay? So every drive over time gets severely fragmented. And the more fragmented, the slower things happen, okay? So if I wanted to, I'm not going to do one that's 67,000 long. That would be crazy. I'm going to pick one down here close to the bottom of the list. I could say, if I, like, for instance, if I knew this was my Skyrim executable file that I want Skyrim to load faster, with this utility, I can click on that one thing and then just say defrag highlighted, and it's going to go, okay, I'm going to go and find those pieces. Here's the pieces, and I'm going to put them all together so that now they're all exist in one spot. So it put them all right there. Okay? So it found all the pieces and it put them all together. If I defragment the whole drive, which would take a really long time. Now, the nice thing is, at least my disk is still good, because 1,989 fragmented files, or 4.4 terabytes of fragmented files, 987,839 total fragments. If I wanted to, I could just say defrag. Okay? And it says, hey, with less than 10% of free space, the defrag will be slow. Because it wants some free space so it can move stuff over there and make more room as it goes. So the less free space I have, the longer it's going to take to defragment it, because it just doesn't have a lot to work with. Okay, so do you want to defrag anyway? I can go ahead and say yes, and then this thing is going to sit here, and it's going to read a part of the drive, and it's going to move something. It's going to read a part of the drive, and it's going to move something. Eventually, it will get it defragmented most of the way. There's some other settings on here, too, that I can do, and I'm going to stop it. I'll leave it going. We'll see what it does while we continue on our discussion.
Is this only with spinny drives?
What? Okay, we're going to talk about that. Okay, so this is the way spinny drives are organized. Okay, and because of the way they're organized and because of fragmentation, we want to run defragmenters on spinny drives. Solid state drives are just stored in memory. You never ever defragment a solid state drive, ever. In any good fragmentation software, we immediately say, this is a solid state drive. Are you sure you want to do this? Because it reads it instantaneously from everywhere at the same place. Okay? So think of a solid state drive as just this big place. There's no seeker head. It can pull off from here and here and here, like just pulls it off. Okay? So we don't defragment. In fact, solid state drives fragment on purpose. And what I mean is, when they write, they're supposed to write to the least written spot whenever they write. So solid state drives wear out. You only get so many writes to this little spot. There's only so many times I can write there before the drive is worn out. You can read to it 1 billion times, but you can only write to it so many times. Okay? So solid state drives keep track of where it's writing, and it goes, I haven't written to that much, so I'll use that instead of this next time I write. Okay? They read way faster, they write way faster, but they are perishable in nature. So, your question, would I put those programs on solid state? You betcha. I don't use my solid state for my data, though. Okay? Just like all the teaching, now you guys are, which is why some of the drives have worn out, and we probably had, 10 that we've thrown away that have just worn out, because you're using it to read and write everything. The teacher's drives have all their operating systems, all their programs on the solid state drive, but all their data is on a secondary spinny drive that's in their computer. Okay? So they've got 2 drives in their computer, and all the programs are on there, so they run really quick, they load really quick, the operating system goes really quick, but all the storage is on the other one so that we don't wear that other drive out. Okay? So yes, you do not defrag
Does the
a solid state
admin have
drive.
the power to choose where downloads go to?
Do what?
Do you have the power to choose where?
Well,
so
the way we have it set up
Yeah.
is that all user folders are on the D drive. They can't pick the C drive. It looks like, as far as they know, just like mine, when I go, a traditional user, when they go to their documents folder, in that downloads folder or the documents folder, all those are traditionally on the C drive. But you can go in the registry and say, that's not where those are on this computer. They're all here on this folder here in the D drive. So every time I access downloads, I'm really doing it to my D drive. Every time I access, so everything happens to the D drive, other than program installs, automatically on staff member machines. Okay? So if you set it up that way, and I have my home computer set up that way too, I've got a 250 gig solid state drive, all my programs, all my games are installed on that, but all my data is on my D drive. Every time I download it, downloads to my D. Every time I save music, save a movie, whatever, it's on my D drive. Because it all lasts longer, and you don't really notice. Okay? How much when you run a game, how much is it using the save file? It's using it for a minute when it loads. Okay? Or when you save. So it's not like my game's going slower because the save file is on the traditional SATA drive. Okay? Okay, so I guess that's enough about defragmentation. I should say the 2 utilities I use, the one I just showed you is called defragler, okay, which is a great utility. And if your system is running slow, and that happens to people all the time, is when I installed Windows, it ran so well, and now 2 years later it runs like crap. Defragment your hard drive. Probably make it like a new machine. Okay? So that's one of those things you can do. Okay, so when we install a hard drive, we prepare for the installation, we connect the appropriate cable, SATA and power cables, we mount the drive in whatever bay, and this is not necessarily in order because many times you want to mount it in the bay before you plug it in. I do. This is the PowerPoint from the slide from the company that made our textbook. I always mount it first before I plug in the cables, but you have to make sure you get both the data and the power cable or it won't work. And then we have to use BIOS to make sure it's on. Okay? Just because we plugged it in doesn't mean a new drive works. In all the computers, all the Dell computers that we have, you have to physically go in and turn it on in BIOS and say, there is a drive here, please use it now. If I turn on a drive bay on that Optiplex 780 in the back, and there isn't a drive, it tells me every time I turn on the computer, SATA 3 is missing. And F1 to continue. I get F1 to continue. Likewise, if I put a drive on SATA 3 and don't turn it on, it will never know that there's a drive there. So we have to tell BIOS to turn it on when we go in there. Okay? When we put it in, there's, depending on the computer, there's any number of bays that we can use. You need to think about the bays you want to use. If you've got a nice case that has a ton of bays here, do not put them up next to each other. They all generate heat. So the last thing you want to do is go and squish them all together. Okay, you'd like to leave air room in between the drives so that they can cool. Likewise, if you have a bunch of drives and you've got a spot right here to put a fan, it would be a good idea to put a fan so it blows across those hard drives and help keep those hard drives cool. Okay. The other thing is that when you're inside a case, all of these metal, and I know we've talked about it before, these are just bent metal. You can cut yourself really easily inside a case. I cut myself on a weekly basis inside cases. Okay, so be careful of that so you don't leave blood on the inside of someone's case. Okay, sometimes they're in bays. I don't know that we have any that has a bay anymore here, but sometimes they used to have bays that came out. I guess these 790s really technically are bays. And what I mean, do you still have drives in them?
Yep.
What I mean by that is that sometimes you don't just unscrew or take out a drive. In the case of these, I have to, see, look, blue means you can move it, by the way, on these little tabs, just like green on a printer means you can move it. Okay, so I have to take out that, and then I have to, there's a little lock down here that I have to push to unlock it to bring this bay out in order to get to the drive. And then it's on a little slidey insert thing here inside there too. Okay, so drives aren't always. Is this the one we pulled from hers?
Yes.
Is it working now? Are we all good over there?
I restarted it and I'm using Newt to find it
Why Newt?
because the IP address either changed or it's not on.
Oh, you mean it's DNS that's not letting you get to it? Okay. Well, it's not going to let you remote to it if you haven't done the B and C thing. Have you done that yet?
Yeah.
Oh, so you've
I
been
remoted to it once. And then I restarted it after GP update, and I'm afraid one of those USB things is making it not.
You may have to go down there. Okay. Okay, so drive should not be moved after secured. Okay, and we didn't talk about that, but I want to. Traditionally, everything used to have spinny drives, right? Laptops, everything had spinny drives. SSD drives are something of the last five years. Laptops are not, or any computer, are not meant to be moved when running. People didn't understand. They thought a laptop meant, I could move it. You know, just the act of walking across the room with a laptop with a regular drive could ruin your drive. Okay? Because especially now, it used to be laptop drives, the fastest laptop drive was 5400. They did not used to make 7200 RPM laptop drives. They do now. The faster the drive spins, it's kind of like a bicycle. When you spin the wheel, you ever spun the wheel on a bicycle and held it up and it kind of torques to one side, right? Because the centrifugal force of the tire spinning. The drive does the same thing. It's spinning so fast, it's trying to move. And when you go and pick up a laptop with a drive that's already trying to bend and walk across the room and do one of these things, you can totally trash your computer, your laptop. Okay? And students used to, they used to put them away with them on, and we'd have to re-image the drives all the time, and we'd have to replace the drives all the time. People all the time close their laptop and throw it in their bag. Well, that's why I wouldn't do this without solid-state drives. If you had a spinny drive and you just closed your laptop and threw it in your bag and went on your way, is the laptop drive still spinning? There is no break. There's no brake. Okay? Now maybe the motor isn't still trying to spin it at 7,200 revolutions per minute, but how long does it take before that spinning stops?
Only like 5 minutes.
I bet you it's longer than 5 minutes. But let's say it's 5 minutes. How many people shut down their computer, their laptop, and let it sit there for 5 minutes on the desk before they went and said, okay, I can move it now? And that's why people have so many problems traditionally with laptops, because they don't know how to treat them. Desktop drives are exactly the same. The last thing you want to do is shut down a computer and then go, whoop, 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 whoop. Okay? It's going to stop spinning. It's still spinning for 5 or 10 minutes. Okay? So don't just grab it and move it after it's been shut down. Okay? You have to be cognizant of that. And really, when we take out a drive, and I've done it before, that I didn't wait very long, and I took out the drive, and the drive literally is doing one of these. Like, you can feel it spinning in your hand. Okay.
Does it make like a loud scratch noise?
If you hear the ratchet noise, you just ruined the drive.
Yeah.
Okay?
That's what
And that's also with that, if you ever hear a clacking noise
That's what happened.
from a drive, you really need to get your stuff off it right away. Okay? It's possible it's still reading, even with that clacking noise, and usually the clacking noise is the head getting stuck on something. Okay? But if you ever hear your hard drive making a sound that doesn't sound normal, get your crap off of it. This may be the last time you have access to it. Yeah.
Okay, so I had a question. You said you put all your games on your solid state drive. What if
Yeah.
I just put my operating system on solid state drive and then just put games on my hard drive and then never did anything else with it?
What do you mean?
Would that still be good?
Yeah, you could do it that way. The games are going to load a little slower, right?
Is it going to be noticeably slower? Not really.
Yeah,
Yeah,
probably.
I'm going to say yeah. Yeah, it's noticeably slow. I mean, are you going to notice it if you never had it on your solid state drive? Maybe not. No.
Alright.
Maybe you're like you're used to the game taking, 20 seconds before it loads up.
Oh, well,
You
that's
didn't
not
know
bad.
it would have loaded
I
in
thought it was gonna be
2.
like a minute.
Well, no, I'm just,
Okay.
I
That's how
mean,
big it is.
realistically, a solid state drive could be 10 times, the read speeds can be 10 times faster. Because just because the data cable, just because this cable transfers at the same rate, does not mean the drive found it, okay, the seek time, and got it, the access time, the same. The seek and read times on a solid state are phenomenally faster than a spinny drive. Once it finds the data, this cable is this cable. SATA 3 is SATA 3. It's going to go across as fast as it can send it. This is not the limiting factor, sorry. Okay? The limiting factor is the drive itself, how fast it can access the data and transfer the data itself. Okay? Okay, so we install the power, we make sure we do the connect it up with the motherboard and to the power when we mount it inside there, and then we have to make sure we set it up on the BIOS. This is just showing an external bay that you could put it in. You can get away with 2 screws on a SATA drive. I would never put 2 screws on two screws on an SSD. I would never only put 2 screws on a spinny drive. I actually screw it in at least 3, if not 4 screws, to make sure that thing can't move around inside your case, because it could move around inside your case. We're doing pretty good on time. Okay, they make adapters for the size of the bay. You can put. Yeah. By the way, I didn't say this, but the other size for CD-ROMs is 5 1/4. You can put an SSD in a 5 1/4 bay.
I heard you got an AMD computer.
I don't know. I got one once. Okay. So, right here. Okay. So you could take.
Because I was trying to be cheap about it. Because I just feel that
You
way.
could take a 5 1/4 bay. This one takes 2 5 1/4 bays and turns it into 3 3.5 bays. And then I got the 3.5 bay, but I can't put an SSD in that. But I got this that I can then put an SSD into to turn a 2.5 into 3.5 into a 5 1/4. I can see my
Is
line.
that an adapter on an adapter?
It's an adapter on an adapter on an adapter. Okay.
Nice.
So there's all kinds of ways to make things fit inside your computer if they don't have the right form factor, and this is just one way that you can do that. Okay. I already said this. We have to go into BIOS and make things are turned on. I'm not going to show BIOS settings because they're all different. You need to find the hard drive settings and make sure you're set up the way you want it to be set up. When we troubleshoot, experience is the best teacher. So we're going to go through some hard drive malfunctions and stuff when we start doing the troubleshooting stuff with chapter 15. The recommends making sure you have backups and you keep those current. And I have an external drive at home that I back up my important stuff on. Make sure you have some kind of antivirus software to keep it from destroying your data, and defrag files when you can. Now, one thing the defragmenter does not do, the defragmenter does not make sure your hard drive is good, which is why this also says that scanning your hard drive is a good idea. I don't know how many of you ever have done this before, but one of the things, do I still have it open? I don't have it open anymore. Let's see if it opens back on this drive. Yay! Okay, one of the things that I can do, I'm going to right click and go to properties again, and I'm going to go to tools, and one of the things that I have the option is this error check. Okay, if I say I want to check and I want to scan the drive, okay, then it's going to go through the, if I go and click scan drive, it's going to go through and it's going to scan the drive. I'm going to cancel it because I don't want to waste the time to slow down my PC, but it's going to scan the drive to see if there are any errors on the drive. Every drive over time gets bad sectors. There are ones that get bad on there. And if you've scanned it and it knows which ones are bad, it won't use them ever. But if you've never scanned it and it doesn't know there's any that are bad, it will use them. And then your Word file that you just saved won't open ever again if it used that sector, right? So that's the advantage of doing a scan on your drive every once in a while. Obviously not when you want to use it. Scans can take a long time depending on the size of your drive. This one is a Velociraptor, so it's a 10,000 RPM drive and it's not very big. It's 279 gig, but if I did it on that 4 gig or 4 terabyte drive, that's my E drive, it would take a long time to do a full scan on that. Likewise, when you install your operating system, one of the options that you have, or whenever you install any disk, says, do you want a quick format? Okay, and you may have done that on yours when you did yours. Quick format is a bad idea. Quick format says, I don't care how the drive is, just let me use it now. And it goes, okay, you're all good. Whereas a full format writes on every single sector on the entire drive, and it goes, oh, this is a bad one, we won't ever use this one again, and it continues on. And now Windows, or actually the controller of the hardware, of the hard drive, knows we're not writing there because this is a bad sector, and I just found out when I did my full format, so it really checks your whole drive when you do a full format of a drive, whereas a quick one does not. So when you do your install, you may want to do the full format on there. Okay, did you watch the video?
I did, and it kind of fixed the problem, but it still wouldn't let me run Windows. It loaded to...
Well, you still have to reinstall completely.
Yeah, I also reinstalled
Okay,
it.
so you deleted the whole with diskpart and then remade it through diskpart, or did you just try to make a primary?
I deleted the one that I had and then made a new disk part. Well,
Is that when you kept texting me telling you couldn't make Windows downloaded?
that was like, oh,
Oh, okay.
Okay, so we'll have to talk about that offline. Okay, so we already talked about this. I wanted to talk about speeds. We already talked about RPM as one of the key speeds, 7200 being what is normal good drive these days, and the fact that the RPM affects how fast the seeker head, that head finds the data, and then how fast it can get the data off. Okay, so it's going to affect the seek, and it's going to affect the read time. The RPM is going to directly affect that. Okay, and then the transfer rate is going to be affected by the kind of SATA, whether it's SATA 1, SATA 2, or SATA 3. That's how fast it can get it off of the drive. So when we look at buying drives, SATA 3 gives us the fastest transfer rate. That doesn't necessarily mean it's the fastest rate you're going to get the data off if it's a really slow drive. In other words, a SATA 2, 10,000 RPM drive might get your data off faster than a SATA 3, 5400 speed RPM drive, because that slower drive is never going to transfer the data fast enough. Okay? So as you do your project, you're going to want to look at those speeds to make sure you're talking about the right things when you're talking about those speeds. And if we have time, we're going to look at some. If not, you're going to look at them next time. Okay, solid state drives. We already talked a little bit about solid state drives. They're going to have, they talk about speeds in IOPS which is input output per second, I think, right? Isn't that what IOP stands for? That's how many. It's a in the thousands how fast it can get things into and off of your drive. It doesn't talk about it exactly the same as SATA does when it comes to seek and access times. Okay, but the transfer or the SATA speed is still really SATA. So it's going to get the stuff, it's going to read it far faster, and we'll look at some of those speeds if we can. But it's going to transfer it whatever data it can read it from, which is why you still get it faster.
What does that stand for again?
The input outputs per seconds on the drive. And it's going to read from all over the drive and then transfer them across that SATA cable. Advantages of solid state drives. Name some.
It's faster.
It's faster, okay. It reads faster. What else?
You won't destroy it if you tip the computer.
It is much more durable, much more durable. That's what I was looking for. Okay, there's no such thing as, you know, if this was a spinning drive and this is a spinning drive and I went like this on both of them. There was one of the videos. Did you guys watch the video on seeing what movement can do to the drive? There's no effect on a solid state drive because there's no moving parts. Because there's no moving parts, it uses less energy. Yeah, it uses less power, so it's going to make your laptop more efficient. Your battery's going to last longer with a solid state drive than it is going to with a traditional drive. Not to mention the speed fact alone that you get from a solid state, but you've also got that power and durability. Okay. There's two other terms you're going to read about when we look at the project, and that's MTBF, or mean time before failure. You may see that on a drive. Okay. It's going to say mean time. It's going to have an MTBF, and a normal MTBF is something like 1 million hours. Okay, meaning that on a laboratory test, based in a lab, in a cold station in their lab, they said that drive will last 1 million hours. Now, if it actually lasted 1 million hours, let's go down to our calculator down here, folks. Calculator. Okay, if it actually lasted 1 million hours, and we divide it by that 24 hours a day, divided by 365 days in a year, they're saying that drive will last 114 years before it fails. It's a theoretical number. It's nice to see an MTBF because it means they've done some kind of testing and they think your drive's going to last a while, but that's in theoretical laboratory conditions. It doesn't necessarily mean that it's going to last 114 years, and that is a normal, sometimes they'll say 1.5 million MTBF. Okay, I'm just letting you know that's all theoretical. The other number that you might see is the annualized failure rate. That comes from actual data on drives that has come out from research on that drive. Okay, and AFR is much more real to me than the MTBF. Okay, in other words, for instance, on this drive, this 3 terabyte drive, 0.85% of them failed in 1 year. Okay, so the lower the annualized failure rate, the better the drive is. It's saying less of them failed that were put out. And you can see this one, that they either failed right away or they lasted 2 years. The failure rate for this drive is higher in 1 year than it is in 2 years, and then it goes back up in 3 years. Okay, that's less than 1%, which means of 100 drives sold, 99 of them have no problem. 1 out of every 100, almost, are going to fail in a year. Okay, not a great rate, really, but if you look, some of these are terrible. This Seagate's 22%. Holy, don't buy that one. Okay. In fact, this was from a website that I just pulled up the other day on the best hard drive failure stats. Okay. Some of them are bad, which is why you want to keep your data backed up. Okay. If you, even the nicest, most expensive drive. I mean, here's a funny one. You know, this one only 2%. This one 20%, but only 47 were surveyed on that. whereas 494 is survey on that one. So, you know, when you get survey numbers that low, I don't know how much I would take that as a real statistic. Right. Okay, so that's what annualized failure rates are. They're the statistical number of those drives that have failed from research. Okay, so AFRs mean a little bit more to me than the other ones. Okay, we already talked about this. Defrag versus Windows Defragmenter. There's some great defrag tools. Windows Defragmenter is not one of them. And then you can also, when you do that scan, it fixes cross links and lost clusters. When you scan your drive, it looks through your whole drive, and that's basically there's a table that says where your drive documents are saved, and it goes through and corrects that table. Okay, so next class, we're going to introduce the project. It's already there. If you want to choose which hard drive you want to present on, you can already do that. If you look at the choice under the project right here, you guys can already do that. And you can already get started reading it if you want to. So right here it says choose your presentation topic, and you can read about the project right there. But we'll talk about it at the beginning of class, and you'll have all next class to work on that project. So if you've already read it, then you just get started from the get-go. Okay?
Wait.
I will see you next class. And for those of you that did not get your projects done, the questions, I guess that's all there is, then we'll be able to do that next class.
I'd wait if you could.
The last thing I want to get is my CPU, so.
Well, I'd wait. At least.
I'm going to pull up that defrag, see how that defrag's going. Okay, so remaining time more than 1 day. Okay. So you can see that if it's really fragmented, especially this one, this is a 6 terabyte drive, and it was 88% fragmented. It's definitely affecting how fast these documents are. But it's a backup anyway.
What I did was, I done looked up.
Yes,
and
I told all them that too.